Good morning all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on linear time invariant discrete time system analysis. See, this is the discrete time Fourier transform. Discrete time Fourier transform is to convert from time domain into frequency domain. It is used for analysis of both periodic and aperiodic signals. See, discrete time signals are analyzed with the help of periodic signals. DTFS periodic signals, DTFT periodic and non-periodic signals. Discrete time Fourier transform describes the spectrum of discrete time signal. DTFT of discrete time signal x of n is given as x of omega is equal to summation minus infinite to plus infinite x of n into e power minus j omega n. This is the DTFT impulse function. L of n is equal to 1 for n is equal to 0. 0 for n should be not equal to 0. While we taking from the impulse response, we can getting the DTFT of impulse response. We can getting the frequency responses x of omega with respect to omega minus pi to plus pi. The behavior of LTI system is completely characteristic by unit sample response h of n. Y of n is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. It is the linear convolution of x of n and h of n gives y of n. When x of n is applied to linear time invariant discrete time system, which can produce the output as y of n. This is the convolution sum of the given sequence. The input sequence x of n can be given. The impulse sequence also given. While we taking the circular convolution, we can give it as your x of 0 is equal to 6, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6. You can multiply with your input sequence into impulse sequence. We can get the circular convolution. And also we can get the linear convolution with response to y of n is equal to summation k is equal to minus infinite to plus infinite x of n into h of n minus n. This is the another convolution sum. X of n is equal to 1 comma 1 comma 1 comma 2 comma 1 comma 1. H of n is equal to 1 comma 1 comma 2 comma 1. Now we can multiply and get the results by using multiplication method. We can get the responses 1 comma 2 comma 4 comma 6 comma 6 comma 7 comma 5 comma 3 comma 1. This is the output of the given convolution sum. It can be classified into three properties: commutative property, associative property and distributive property. Commutative property, y of n is equal to x of n into h of n equal to h of n into x of n. When x of n applied to h of n, which produces as y of n. H of n is applied to x of n, which produces as output as y of n. Next one, associative property, x1 x of n multiplied with h1 of n again multiplied with h2 of n, which is equal to x of n into h1 of n into h2 of n. X of n multiplied with h1 of n again multiplied with h2 of n, which produces as output as y of n. Right hand side sequence, x of n multiplied with h1 of n into h2 of n, which produces output as y of n. Distributive property, x of n multiplied with h1 of n plus x of n multiplied with h2 of n, which is equal to x of n into h1 of n plus h2 of n. X of n multiplied with h1 of n, h2 of n, that can be added with two signals, which can produce the output as y of n is equal to x of n into h1 of n plus x of n into h2 of n. X of n multiplied with h1 of n plus h2 of n, which can produce as output as y of n. Next one, difference equation. Difference equation, there is an efficient way to implement discrete time systems. The convolution of input sequence x of n and unit sample response h of n, which can produce as a output as y of n, is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. Two types of difference depends upon the length of the unit sample response h of k. This is the recursive difference equation. Y of n is equal to y of n minus 1 into x of n minus 1 plus 0.5 into x of n. X of n multiplied with 0.5, we can get it as a 0.5 into x of n. That can be added with x of n minus 1. Is that inverse into x of z? We can get it as your x of n minus 1. Again multiplied with y of n minus 1. Is that inverse into y of n minus 1, which can produce the output as y of n. Next one is Z transform. Z transform is used for the analysis of discrete time signals. It is more broad compared to discrete time Fourier transform. It is very much useful in discrete time signal as well as system analysis. X of n and X of Z is called as Z transform pair while we converting from S plane to Z plane. This is nothing but ROC. System transfer function of linear time invariant DT system. Ratio of the output to the input H of Z is equal to Y of Z divided by X of Z. Frequency response H of omega is equal to Y of omega divided by X of omega. This is the Z transform unit circle ROC. When A less than 1 means the outside of the greater than that is nothing but less than ROC means less than A is nothing but ROC. 1 divided by A greater than ROC means 1 divided by A, the first circle represents A, second circle represents 1 minus A, outside inside the circle is nothing but ROC. A greater than 1 means outside the circle is nothing but ROC. Therefore 1 divided by A less than 1 means inside inner circle, inside of the inner circle is the ROC. Next one, linear time invariant discrete time system. Y of n minus 1 gives Z inverse into Y of Z plus Z into Y of minus 1. Similarly for Y of n minus 2, Z power minus 2 into Y of Z plus Z inverse into Y of minus 1 plus Z into Y of minus 2. Y of n minus 3 gives Z power minus 3 into Y of Z plus Z power minus 2 into Y of minus 1 plus Z inverse into Y of minus 2 plus Z into Y of minus 3. This is the shifting property of unilateral Z transform. Determine Z transform of X of n is equal to U of n. Summation n is equal to minus infinite to plus infinite X of n into Z power minus n. U of n is equal to 1 for n greater than or equal to 0, 0 for n less than 0. Now we can multiply with 1 into Z power n. Limits varies from 0 to infinite. We can get 1 plus 1 by Z plus 1 by Z square plus 1 by Z cube up to etc. 1 plus a square gives 1 divided by 1 minus a. We can get it as here Z divided by Z minus 1. Modulus of Z should be greater than 1. When X of n is equal to del of n means X of Z is equal to summation n is equal to minus infinite to plus infinite X of n into Z power minus n. Del of n is equal to 1 for n is equal to 0. Therefore, X of Z of unit impulse function is nothing but 1. Applications of Z transform. It is used to analysis of discrete time signals. It is used for digital signals. It is used to solve the difference equations with constant coefficients, to characterize the transfer function of discrete time LTI system, to design a digital filter. Now we can see the assessment. What is mean by DTFT? Discrete time Fourier transform is defined as X of omega is equal to summation n is equal to minus infinite to plus infinite X of n into e power minus j omega n. What is mean by linear convolution? Linear convolution means X of n and H of n be the input function which can gives the output as Y of n. Y of n is equal to summation k is equal to minus infinite to plus infinite X of k into H of n minus k. Y of n is equal to X of n into H of n is defined as commutative property. Define Z transform. Z transform is defined as X of Z is equal to summation k is equal to minus infinite to plus infinite X of n into Z power minus n. ROC of Z transform can be used to determine the causality of the system. The system transfer function of linear time invariant DT system is H of Z is equal to Y of Z divided by X of Z. Thank you.